Okay, let's do another one here, and I'm going to let you guys I'll describe the problem, and then I want you to pause it and see if you can figure it out. Okay, so let's look at this. I'll try to get you unstuck on it before I just cut you loose. So we have another car wreck here. It's an inelastic collision, so the two cars are going to stick together when it's done. And this is 800 kilogram car moving at 9 meters per second up this direction. And it encounters a 1,300 kilogram car moving at 14 meters per second, moving this direction. They collide. We're going to say that's an inelastic collision, so the cars stick together. And we want to know the velocity of the wreckage, which is the speed and the direction. Okay, that's what we need to figure out. Now we've used this horizontal line as our reference point, so why not continue doing it that way? But you really can use any angle that you want, and but you have to measure the angle against something. So this horizontal one is probably the way to go. Now the way to do this is to figure out the horizontal and vertical components of the momentum of each vehicle. Okay, so this one is moving sideways, so it's going to, all its momentums be horizontal and none vertical. This one, though, is moving at an angle, so it's going to have some of each. So you got to figure out the vertical momentum of this guy and the horizontal momentum of this guy. And then you add together all the vertical momentums and all the horizontal momentums, and then that will give you the vectors of the wreckage. Then you Pythagorize and do the same thing that we did in the last problem. Okay, so at this point, pause the video, see if you can get through this on your own without any help, and then watch it if you get stuck or to see how it works out. Okay, so we're going to call this one car 1, and we're going to call this one car 2. So car 1, momentum in the x-axis is 1,300 times 14 meters per second, which equals 18,200 units, 18,200 units that way. And the momentum in the y is equal to 0. So no momentum upward for car number 1. For car number 2, we have the momentum is equal to 800 times 9, which equals 7,200 kilogram meters per square, and it's in that direction. So now we need to break this momentum into vertical and horizontal components. So we have a triangle. This side is 7,200. Yes, it is. And there is an x component, and there is a y component. And this angle here is 30 degrees. Okay, we use SOHCAHTOA to do this. So the sine 30 degrees times 7,200 equals, and the cosine 30 degrees times 7,200 equals, we'll do both of those, times 30 sine equals, so 3,600 units, and 30 cosine times 7,200 equals 6235, 6235. Okay, now by looking at the triangle, we can tell that the x, it's moving sideways more than it's moving up. So the px is equal to 6235, and py is equal to 3,600. That is to say, the momentum along the x-axis is 6235 units. Momentum along the y-axis is 3,600 units. So now we have the horizontal momentums and the vertical momentums. And really, I should put this arrow the opposite direction because it's a negative. It's moving to the left. So now we add these together to find the total momentum of the wreckage, because the momentum of the wreckage includes or equals the momentum of the two cars that combine to make the wreckage. So we'll come over here and we're going to go for the PX total. That's the horizontal is equal to 18,200 minus 6235 because they're in opposite directions. That is going to equal 11,965, and it is in that direction. The total vertical, the Y momentum, is just what the this car here, car number 2, brought into it. So that is 3,600, and that is up. Now we make a triangle out of this to see how it works out, and we have 11,965 on this side and 3,600 on this side. We are going to try to find the total momentum, which will give us a total velocity, and we're going to try to find the angle. Okay, that's what we need. So first for the momentum, we have 11,965. We're going to square that plus 3,600 squared. We'll take the square root of it. Pythagoras is our friend, and this comes out to be 12,494. That's the momentum. So P is equal to 12,494, and that equals the mass of the wreckage times the velocity of the wreckage. And the mass of the wreckage is 1,300 plus 800. So that is 2,100 kilograms times V. So that means that V, divide this by 2,100, comes out to be 5.9 meters per second. 5.9 meters per second. And now the angle, tangent theta equals opposite over adjacent. So that is 3,600 divided by 11,965 is equal to tan theta. So 3,600 divided by 11,965. This number is the tangent of the angle. So we take the inverse tangent of that number and we get 16 degrees. Theta equals 16.7 degrees. So our final answer is, for the speed and direction of the wreckage, is 5.9 meters per second at 16.7 degrees above the horizontal. Above horizontal. So that's saying that the wreckage is going to be going out this way. Okay, and this angle here is 16 degrees, and it's been moving at 5.9 meters per second. That's our answer. Always a good idea to check to see if it makes sense. Okay, so basically, it didn't get deflected upward very much, and that kind of makes sense because this is a lighter car going slower than this big car. So the momentum of this one is going to dominate, and the momentum of this one coming in is only going to deflect it upward a little tiny bit. Okay, only 16 degrees. Now, what about the speed? We go 14 meters per second and 9 meters per second. We might wind up with 5.9 meters per second. And this also kind of makes sense. This is almost a head-on collision, and this one has a lot more mass. It's going a lot farther, a lot faster. So it kind of makes sense that it would drive this guy backwards. So they collide, and the heavier car dominates, and it does make sense that the wreckage would go this way at a lower speed. Okay, so that's a reasonable answer, and that's what we get. I hope you're able to get through that. Let's see, I think I have, yeah, everything's visible from where I have my my smiling face here. So yeah, that's all that. Let's see, do we have anything more on that one? I think that's it. Okay, we'll pause it here, and if we need to put more in at the end, we'll put more in at the end.